Hello dear students, in this class we are going to study one more topic, that is the polynomials. So then, already in the yesterday we studied about the algebraic expressions. Algebraic expressions. So then, what is that algebraic expression? So already you know that one is the term which has a variable in that the constant terms that we call as the algebraic expression. X plus 4 is the algebraic expression. Here variable like constants are ordered with the plus minus into dividing one of the sign including that, so variable and constant is that we call as the algebraic expression here. So this algebraic expression is only the polynomial. So algebraic expressions only be called as the polynomials. But what is the difference between the polynomials and the algebraic expression? Only is that one. The some particular algebraic expressions only we can call as the polynomial. For example, what will happen? So algebraic expression is in the form of negative index, in the form of negative index, that we now consider as the polynomials. Polynomials are the algebraic expressions only, but with the positive exponent, otherwise positive index. The algebraic expressions which has the positive exponent, that we call as the what polynomial, otherwise non-negative exponents of the algebraic expressions are called as polynomials. So only thing, the index, otherwise degree of the algebraic expression must be positive. So that positive degree of the expressions are then is that we call as the polynomials. So polynomials are also algebraic expressions of non-negative exponent. Okay. So then, so here the polynomials p of x in one variable. What variable is this? Different from the algebraic only x. So one variable may be, it may be x, y, z in one of the variables we have to consider. That we call as algebraic expression in one variable. So then here polynomial of degree, polynomial of one variable, that is a polynomial p of x variable. Only one variable, that is a x variable. So here this is the general form of a polynomial. A n x n plus a n minus 1 into x n minus 1 plus so on a1 x plus z. We report this one. So a0, a1, a2, an are respectively the coefficients of xn minus 1 so on x. Yes. So here what will happen? So here whatever the a0, a1, a2, these all are the coefficients of what? xn minus, otherwise x0, x1, x2. So here a is the coefficient of xn, an minus 1 is the coefficient of xn minus 1, a is the coefficient of x, and a0 is the coefficient of x0. Given. So these we call as the coefficients and variables of the polynomials. For example, consider the 3x. So here x is the variable, 3 is called the coefficient of x. Coefficient is that is a constant. That is a constant. So whatever the variable, whatever the numeral is there in front of the variable, that is called as the coefficient of that variable. So then x1, xn, xn minus 1, x1, x0 is all called the variable of the polynomial. So here types of the polynomials are shown. And n. So whatever the n minus 1, but here is 1. So these all we called as the degree of the polynomial. So here n is called the degree of the polynomial. Here highest power is n. So if we consider this both is a polynomial, highest degree of this polynomial is n. So that we call as n is the called as the degree of the polynomial. For example, here is to consider the 3x squared plus 4 x plus 1 is the polynomial of degree of x, polynomial of the variable x here. So then what is the degree of the polynomial? The highest power is 2. So degree of highest power of the exponent is 2. So that's why that we call as that polynomial degree is 2. So second degree polynomial degree is 2. So then types of the polynomial also will be considered. So what are the types of the polynomial? There are 3 types of polynomial. So zero polynomial also will become. So but we will consider monomial, binomial and trinomial. So what are the monomial, binomial and trinomial? So here, so this is, I told this is the polynomial. So how many terms are there? 1, 2, 3 terms. Yes, sir. So the polynomial of which has only one term, the polynomial which has only one term, that is called as a monomial. For example, 4x. So this is what monomial. Only single term is there is only one term it has is that is called as the monomial. So next one will become a binomial. So what is a binomial? So name only indicates bi means two here. So the which polynomial contains two terms here. For example, 5x plus 4. So otherwise 3y minus 1. So sign is no matter. So only what is the terms? How many terms? Okay, 5x is one term, 4 is another term. Here also 3y is one term and 1 is one term. So the polynomial which contains two terms that is called as the binomial. So next one will become a trinomial. What is a trinomial? The polynomial which has a three terms, which has a bi means three here. So polynomial which has three terms that is called as the trinomial. So here 3x is one term, 4x is another term, and 1 is another. So totally 1, 2, 3 terms. The polynomial which has three terms that is called as the trinomial. So one more thing will become whether what is this? You have to take a 2. So if you take x, you will take yes, x is the polynomial of one term that we call as a monomial. So here, if x is a polynomial, then 2 is a polynomial 2. Otherwise, any constant will be 4. Otherwise, 5. These are the examples of polynomial s or no. So yes, these are also called as the polynomial of the degree 0 here. So that's why these polynomials we called as the these 2, 4, 5, 0. That we call as the 0 polynomial. Why we call these other polynomial 0 polynomial? Because here does not contain variables. Here does not contain variable means nothing is there which we can call right in front of the any variable to the power 0. So according to the exponents, laws of exponent, a to the power 0 in that will reduce as 1. So here 4x to the power 0 then is equal to 4 into 1 that will reduce as 4. So means 4 is also and 5 is also 2 means also these all are and minus 4 minus 2 these all are the polynomials. So what that the 0 degree polynomials or that we call as a 0 polynomials. 0 polynomials, monomials, binomials and trinomials. And 0 polynomials are always under degree 0. Degree of the 0 polynomial is 0 because a variable is contained that has a power 0 here and the value of that x to the power 0 is 1. So 1 into 4 that will be 4 only. So that's why the degree of the any constant that will become a 0 polynomial is always 0. So got now? So what is the polynomial? Index of the polynomial and example of the polynomials. These are about the introduction of the polynomial. Already studied about the algebraic expression. So next part of algebraic expressions is polynomials. Best example for the polynomials is algebraic as it is a plus b whole square, a minus b whole square, s minus b square. So these all are the good examples for the polynomials. So because they are the what the standard form of the algebraic expression. So that's why we can write the example for the polynomials that also. So because they are the non-zero exponents, they have all have the non-zero exponents. So okay, we will go for the next year. So here's some example we will see that. So here consider examples here. So here x plus 1 by x, second one x plus 3, third one is you dot y plus y square. The question is whether the examples are polynomials. So whether these three are polynomials or not. The question is asked. So whether these are polynomials, see here. So x are written plus 1 by x, we can write as x to the power minus 1 by x. X to the power minus 1 by x. Yes or no? So like that we can write here. So what we do? X to the power minus 1. So in here, degree is negative. This is algebraic expression, okay. So these are the algebraic, but the exponent is negative here. If the algebraic expression has a negative exponent, means that is not a polynomial. So what will be the algebraic expressions which have non-negative exponents with whole numbers, which are non-negative whole number exponents with whole numbers. So what is this how to be? It has to be positive exponent, because that has to be, must be whole number. So but here minus 1 is the whole number and it is a negative number. Yes sir. So otherwise the algebraic expression which are the exponent whole numbers, that is called as a polynomials. So here this is a negative term, index is negative, means it is not a polynomial. Yes. So the term of the second case, 2x plus greater than is the polynomial, just like the here. This is the polynomial, like that expression we will do. So but 2x we can write as a x to the power 1 by 2 plus 1. So here 1 by 2 is 3. This 1 by 2 is 3. Polynomial whole number, no. 1 by 2 is not a whole number. So what we have here, exponent is not a whole number. Otherwise the index of the variable is not a whole number. So that's why it is not a polynomial. So what will happen? Whatever the exponent is, that must be a whole number. That has to be a whole number. Otherwise, non-negative exponent. Non-negative exponent or whole number. So here 1 by 2 is not a whole number. So that's why second example is also not a polynomial. So that is algebraic expression. Okay, I will agree for that. But all the algebraic expressions are not a polynomial. All the algebraic expressions are not a polynomials. So these all are not a polynomials. All algebraic expressions are not a polynomials, but all the polynomials are the algebraic expressions. All the polynomials are algebraic expressions, but all the algebraic expressions are not polynomials. See here on the example, 2x plus 3 is the algebraic expression. I will have to cover it, but this is not a polynomial because here exponent is not a whole number. Exponent is not a whole number. Get it? So then next one. So here were cube root of y plus y square. So cube root of y, since we can write this as 1 by 2. Cube root of y means we can write this as 1 by 3 plus y square plus y square. So 1 by 3 is a whole number here. So no, 1 by 3 is not a whole number. This 1 by 3 is not a whole number. So that's why third one example also not a whole number. So conclusion you can write here. First one example, so here minus 1 is not a whole number, so the given expression is not a polynomial. Here other second one, 1 by 3 is not a whole number, so given expression is not a polynomial. So 1 by 3 is also not a whole number, so that's why given expressions. So here whatever the examples they given, in all the examples, the exponents are not a whole number, so that's why given examples are not a polynomials. Getting? So compare this one. The degree of the polynomial. So just when I explained, the degree of the polynomial is the polynomials with the highest degree. The variable in the polynomial which has the highest degree, which variable has the, which term has the highest exponent, and exponent time equal to the degree of the polynomial. So here p of x in this first expression where is the variable in this equation, otherwise in this polynomial. So here x is the variable. Yes, x is the variable, means degree of the x is what here. So degree of the x is what? So nothing the given is the, we have to consider it as a 1 here. So therefore this is called as the 1 degree because degree equation. Degree of the equation is 1. Degree of the polynomial is 1 here. Second one. So p of x equal to x square minus x. So in x square is greater than x to the power 1. So you have that 1 is greater or 2 is greater. So 2 is greater. So that's why this is a 2. Here 2 is greater means second degree polynomial. Degree of expression degree is 2 or second degree or also degree. So here R2 or so y the power is 3. Therefore degree is 30. Yes. So highest power in these all which is the highest mathematical power is a polynomial. That is the degree of polynomial. So p of x is equal to x plus x squared plus 5. So here x to the power 1, here x to the power 2, here y is a constant. So here highest degree is here 1 is there, here 2 is there. Which is the highest? 2 is the highest. That's why degree is 2. Degree is 2. So compare q of x here 2x plus x minus x to the power 2 here. So means so don't get confused. Root 2 is there, means this is not something like that. Because here root x means to variable has a root, but here constant has a root. Here constant has a root. So constant maybe it has here irrational number. So but root 2 is the not a constant term variable that does not consist of variable. Variable consists that is a zero degree variable. So this is the example for polynomial. Only thing the variables does not have the roots, values and all. So here x root 2 plus x minus x square. So which is the nearby is the and the highest degree is 2. So again here degree is 2. Second degree polynomial. So know that the degree of the non-zero constant polynomial is 0. So degree of non-zero exact 0 constant polynomial. Constant polynomial say 2, 3, 4 example. Example you can take 2, 4, 6, 5, minus 5, 10, minus 10. Anyhow, so any constant that has 0 because of here 3. So 3 we can write 3 x to the power 0, 3 into x to the power 0. X to the power is 9, we can write 3 into 1 that is 0. So this is a constant polynomial. 3 is a constant polynomial and that has a degree 0. So that is called 0 polynomial also, otherwise constant polynomial also with degree 0. Ready? So now here one example from your textbook. Find the degree of each of the given polynomial. Here how many polynomials are given? 1, 2, 3 polynomials are given. The first one is x to the power 5 minus x to the power 4 plus 3. Yes, x to the power 5, x to the minus x to the power 4, x to the plus 3. So which degree? So degree of the polynomial. How to find this one? So we have to check out all the exponents. 5, 4, 4. So which is a greater here? So which is a greater number? 5. 5 is a bigger means here we can write as a degree of the polynomial is 5. Degree of the polynomial is 5. So next one here. 2 minus y square minus y cube minus 2 into y square. So then here polynomial is decrease. Here exponent is 2. Here 3 and here 8. So highest is 8 here. Where either it means we have to take this as a degree is 8. Degree of the polynomial is. So one more thing, don't get a mistake that one. So teacher told me the highest degree, so I want to be at 2 plus 3 is 5 plus 8 is 13. So means we can write the degree of the polynomial is 13. So don't do that mistake here. So that is totally wrong. So we have to observe only the degree which is a bigger number that is the degree of the polynomial. Getting? So but once if they ask get something good like this, what's going to take this? 3 y plus 4 y to the power minus 2. And then give like this and write the degree of the polynomial. So just like that. So if what you will write here, so here 1 is there given, and this is 1 here minus 2. So then what is the minus 1 is greater than minus 2 and degree of the polynomial is 1. So but that is totally wrong because just before like the polynomials means that has to be a degree of the exponents. The exponents has to be whole numbers. But here minus 2 is not a whole number. This is a negative. Minus 2 is a negative number. So that this is not polynomial. So 3y plus 4y to the power minus 2 that is not polynomial only. So there is no need to write any degree. So if that they ask you what to do then you will get. So whatever the example they given. So whatever the algebraic expression they given, that is not an example for polynomial. So we can't able to write the degree of the polynomial. Like that reason you have to give otherwise. If you write 2 minus 2 1 in there, so that will be considered as a problem. So next one here. What is the degree of the polynomial here? That's only I given an example here. That is the degree of the non-zero constant variable. Constant polynomial is more than 0. So here non-zero constant polynomial. This is not a 0 and 2 is a constant. Yes, and variable is 0. Variable is of the degree 0. So that's why the degree of the 0 is. So the degree of the polynomial is 0. Otherwise we can write in the constant. It is a 0. So non-zero constant polynomials. Non-zero constant polynomial and that's degree is always 0. So this is about the what are the algebraic expressions, what are the difference between polynomials and algebraic expressions. degree of the polynomials, how to find, and how to get which is the highest power of the polynomial. Highest power of the polynomial only the degree of the polynomial. What? So we will see some more examples. So here are some more examples on degree of the polynomial. Consider. I have here 4 group examples. Okay. So we will see one by one. First example. P of x is equal to 2x plus 5. The 2x plus 5 here the degree of the polynomial. So here the variable of degree exponent 1. So means this is the degree is 1. This variable degree is 1. Variable is x and the power of the variable is 1 here. This is the degree of the equation. Polynomial is 1. So here 4y. It is only one term. That is only this one is that. So then here degree of the y is continuous. That is we have to 1. So degree of this polynomial also 1. So next one is r of t is equal to t plus 2 here. So here variable is t and the variable is 1 here. So exponent t has a 1. So this is the degree of the polynomial 1. So here yes, t minus 2. So here it is a variable and the power of it is 1. So highest power of this polynomial is 1. So that's this is also degree of this polynomial is 1. So in this examples, in 4 examples, the first all have a degree 1. All is a degree 1. So this type of the polynomials means the polynomial of degree 1. The polynomial which has a degree 1. So that polynomial we call as a linear polynomials. That polynomial we call as linear polynomials. So all like an algebraic expression, the degree of the algebraic expression is 1. That we call as a linear algebraic expression. Linear equations. Yes, or linear expressions. Okay. So these equal as the linear polynomial. Linear means that is 1. So 1 means that the degree of the all the polynomials has 1. So that is these all are examples for linear. This type of examples is called the linear polynomial. So like come for the second one here. So here x into x square plus 5. So x is the variable here. So for the variable and then on the polynomial exponent of the variable. So exponent of x is 2 here. Exponent of x otherwise the power of x otherwise 2x of x is 2. So highest exponent x and x indicate other variable is the denominator. So only one variable that is x and the power is of that x is 2. So means degree of this polynomial is 2. So here how many 2 times here x is there. This 2 twice this is the trinomial which has 2 variables here. So x here x power is 1 and here is 1. Here x to the power 2. If the power is 2 and here is 1 which is a greater, who is a greater and this is also power 2 and this is 1. That's variable. Variable is also 2. So come for the here are 2 variables are there x square and x. Okay. So here 2 is there, here 1. 2, 1, which is greater, 2 is greater, so that's why this is also polynomial of degree. So here only x square is there and the degree of that x square is 2 here. Yes, that variable, that x variable is here. So this is also degree of 2 here. So in this second one, all the examples, all the polynomials of degree 2 here. If the polynomial of degree 2, if the polynomials has a degree 2, so that type of the polynomials we call as what? Quadratic polynomial. Quadratic polynomial. Quadratic polynomial. Linear polynomial like quadratic. So polynomial of degree 2 are called as a quadratic polynomial. Or means to get quadratic polynomial. So come on the third one. So here 4x cubed. So only x is the variable. The power of this x is 3 here. So highest power is 3. This is the third degree polynomial. So here 2x square plus 1 is okay. So here there is a variable x as a variable and power of x is 3. So x and that x cube 1 is the variable here. Only 1 variable is there. So then that variable exponent is 3 means highest degree is 3 also. So that's why that is a third degree equation. The third degree polynomial. So here how many 2x cube 4x square 6x plus 7. So how many 1, 2, 3, 7. So here x square x cube. So in this all the x's on the powers here 3. here 2 and here 1. So which is the greater here? 3 is the greater, so this is the highest probability is that is also third degree polynomial. So then in the third all the degree of the polynomials are 3. Degree of all the polynomials is 3. So here the degree of the polynomials are 3. Otherwise third degree polynomials will be called as a cubic polynomial. These all are examples for cubic polynomials. So these are cubic polynomials. First one is a linear polynomials, quadratic polynomials, and somebody cubic polynomials. So here, so 2. So here the variable is not always, this is 0 degree. Here also not variable is 0. Here also variable is not variable is 0. So this non-zero constant is always has a 0 degree polynomial. So these type of the polynomials we call as the constant polynomials. Constant polynomials. The equations in the polynomials which has a 0 degree, that polynomials is called as a constant polynomial. Since we have checked whatever the numbers you can choose and the degree of that number will become 0. So then what about these all are non-zero? What about this 0? What is the power of 0 here? What is the power of 0? So if alien to 0 is God, this will be called as this we call as the 0 polynomial. This is the example for 0 polynomial. If this is a 0 polynomial, what about the degree of this 0 polynomial? So always the degree of 0 polynomial is not defined. Not defined. So degree of 0 polynomial is not. So degree of 0 constant polynomial is 0. Degree of cubic polynomial is 3. Degree of quadratic polynomial is 2 and degree of linear polynomial is 1. Degree is 1 linear polynomial. Degree is 2 quadratic polynomial. Degree is 3 cubic polynomial. Degree is 0 constant polynomial and 0 polynomial. Degree is non-defined. That is examples for all the degrees and the type of the polynomials. So what are the linear, quadratic, cubic, constant polynomial and non-defined? 0 polynomial. So 0 polynomial is only 0. Except all the only 0 we got as 0 polynomial. Except that 0, whatever the constant terms are there, 2, 3, 4, minus 6, minus 10, whatever the numbers are there, that we got all the that we got as a constant polynomial. And after whatever the terms we got that we got as a linear polynomial, quadratic polynomial, and cubic polynomial. What I hope you all understood. So this is about the introduction. In today's class I told whatever the types of the polynomials and the degrees of the polynomials and example of the degrees of the polynomials. So then, I hope you all understood. So in the next class we are going for the zeros of the polynomials. So today class in this one only I will do how to write whatever I wrote on the board. So you have to watch clearly everyone and watch you write in your classwork. So it is very better example for which type of whatever the definition I am telling and the linear polynomial, cubic polynomial, quadratic polynomial, that everything you have to do well. I hope you all understood. Keep studying. Thank you so much.